Hello everyone, today I'll be talking about the intuition behind elasticity. Elasticity is the responsiveness of quantity either demanded or supplied to a change of price. So basically, all of us will know this definition. However, not many of us actually know what responsiveness actually means. So I will going to explain the intuition behind responsiveness. In fact, what elasticity means is how much the demand will change if there is a change in price. So here I will give you an intuitive way of differentiating between the perfectly elastic demand and the perfectly inelastic demand. So over here in graph B, we can see that there is a demand curve. So how do we know that it is a perfectly inelastic demand curve? Well, we first look at quantity demanded. As the prices increase from 0 to 3,675, we can see that there is not much increase in demand. In fact, the demand stayed the same at 220. So that means, given that no matter how the prices change, the demand will stay the same. An example, popular example would be insulin products, because people with diabetics would have to consume insulin regardless of how much it is going to cost, because it's basically a necessity. So then looking back at our graph C, here you can see that the price stays the same in this graph. So we can see that even an infinitesimal small increase in price will lead to an infinite increase in quantity demanded. So basically the price will stick at $3.3 per kilograms when you can purchase 176 units to an infinite units. So what does that mean is that any little change of price will lead to an infinite increase in quantity. Here, an infinite increased quantity means that it is really elastic. It is really prone to change. So that's how we distinguish between perfectly elastic demand and perfectly inelastic demand. So moving downwards to another popular graph that is going to be shown by your teachers, most likely, if you are taking any sort of economics class, is this graph. On the top part, you can see that the teacher will tell you that this section is the elastic portion where the elasticity is less than -1. And over here, it's the unit elastic demand. And down here is an inelastic portion where the elasticity is between 0 and -1. A lot of times we just ignore the negative sign and just assume that everything is positive just for the simplicity purpose. So let's first delete all of that and see why that is the case. So first of all, we would like to look at the initial starting point, because looking at the boundaries conditions, the intercepts usually help us to get an intuitive feel of what that actually means. So over here we can see that initially we are actually consuming or wanted to demand 0 units of the pork. As we increase our demand of pork by a little bit, say by 1 unit, then we can see that in terms of percentage, the percentage increase of quantity demanded is actually 1 minus 0 over 0, which is basically infinity. So there is an infinity increase in quantity demanded in percentage terms. Well, let's look at the y-axis here. So initially we were wanted to demand 14.3 units, and then we were moving down a bit, let's say to $12. Then it's about like 12 minus 14 over 14. We don't have to get to the specifics of that. That's about like 15% or so. So let's say because the quantity change in terms of percentage is much larger than the percentage change of price, and we know that the elasticity is the percentage change of quantity demanded over percentage change of price. So that will be at the top, which is an infinite number, which means that this point will give us an infinite elasticity, which is perfectly elastic. So that matches close enough to what we were assumed to be happening at this point. So let's move on to another point, which is over here. We can actually use similar logics. At this point, the quantity demanded will be, let's say, from 260 to 280. That's over the initial, which is 260. So that is the change in quantity demanded, which is a pretty small number. It's like less than 10%. Less than 10%. Well, let's look at the y-axis. The price is probably going to change from 2 to 0, let's say. It's not an exact number, but it's just for illustration purposes. The price would change from 2 to 0 over 2. You can see that the downward, that is the elasticity over here. Can see the downward side is 1, while the upper side gets smaller and smaller as we get close to this point, while this will basically stay the same all along. So which means that they will give us a close to 0, which will be closer and closer to 0 as we approach this point. So that's basically an intuitive understanding of why that is the case. Let's delete all of that. And finally, I wanted to show a little bit about the mathematic intuition behind this. Let's zoom in a little bit. So over here, we can see this formula. So someone would wonder, how do you get this formula? So actually, this formula is exactly the same as the formula you will see for elasticity. So let's write out the elasticity formula, which is delta Q over Q over delta P over P, which is equal to delta Q over Q times P over Q. So looking at that, you can see that actually, oops, I messed up with one of the figures. That should be delta P when we flip it up. So that will be exactly the same as the formula over here, because delta Q over delta P is essentially the derivative of the demand curve, which is dQ over dP. And look at that, we have a straight line of demand curve. So that means that the derivative, which is the slope of the demand curve, is actually a fixed number. And because it's downward sloping, so it's negative b, it makes a lot of sense for it to be negative b. And P over Q will vary along this curve. That's why it gives the points different elasticity. Over here, let's go back to this point over here. The price is 14.3 over here, and the quantity is 0, which means that the P over Q over here will be an infinite number. When an infinite number times a negative B, it will also give an infinite number. So that makes sense. That is perfectly elastic. And then let's delete that. We can see, looking at this part, which has 280 millions of quantity, which is 280 over here, and 0. Oops, sorry, it's the other way around. It's the 280 here, and the price is 0, which will give us 0 for this point. So as you can see, that mathematical relationship will also justify whether it is perfectly elastic and whether it is perfectly inelastic in this point, and why would elasticity change along the straight line demand curve. Thank you very much. That will be it. See you next time.